Buongiorno a tutti e benvenuti a questo nuovo evento Ocrim
Good
Webinar.
afternoon, everyone. Welcome to this new Ocrim webinar dedicated to maintenance and automation for management and proper operation of machines for milling news. Thank you for your participation, and I remind you that the event will be entirely in Italian and simultaneously translated into English, Spanish, and French, and you can activate the language translation through the drop-down menu at the bottom of your screen.
I remind you that you can select the simultaneous translation in English, French, or Spanish language by using the drop-down menu on the lower part of your screen, because this event will be completely in Italian language.
Before introducing today's topic, I will introduce myself. For those who don't know me already, if you have not participated in the previous webinars, my name is Nicola Riboldi. I'm a mechanical engineer at Ocrim's machine office at the new Ocrim plant in Cremona. Today we have Sergio Manfredini, historical engineer of Ocrim, an expert. Hello, my name is Sergio Manfredini. I've worked at Ocrim since 1995. When I'm here, I work on design of milling units, and I travel abroad for testing of plants and machines. So I've already worked with some of you. I've worked in your plants, and good afternoon to all of you who already know me. Today, we're talking about plastic sieves, Ocrim plastic sieves. We'll analyze the differences and benefits of Ocrim plastic sieves compared to traditional wooden sieves coated with formica layers. Sergio will help us on better understanding the differences and the benefits from the technological point of view, and also for considering his field experience. And I will tell you about the aspects characterizing the sieves from the technical and construction points of view. Before we move on to today's webinar, today's event will last about 30 minutes, and at the end, if we have enough time, we will dedicate time to questions and answers we receive through the chat. If we don't have enough time, you can send us your questions to our email address, conferenceroom@ocrim.com, and we will be pleased to reply as soon as possible. We can start, I would say. As we all know, during the last few years, focus on high quality of finished products has been growing more and more, especially from the point of view of food sanitation. The subject of food sanitation has had consequences on the choice of materials suitable for food contact. In fact, in the last few years, Ocrim has invested a lot in research and development to identify appropriate materials in the market for food contact to make its components in its machines. In this case, we're talking about sieves, of course, which are the heart of a mill. And Ocrim has decided to change from wood coated with formica to plastic. When we talk about plastic nowadays, we refer to a broad world, diversified world. So Ocrim, within this world, and after research and development investments, has decided to focus on two plastic types. The first is so-called green plastic that we can see here, and we can see with this light brown color. It's also called green plastic. On the other hand, we have antimicrobial plastic characterized by this other color. At this point, usually questions ask us, what is the difference and benefits and the advantages of plastic sieves compared to the previous wooden sieves? First of all, uh, it often happens to me to open plant sifters. I've been worked for years, and wooden sieves with formica are broken or worn down by the operation. So wood gets in contact with flour, so with contamination, possible contamination of flour. Whereas when we have this plastic material, the entire sieve is made with the same plastic material. So even if the material is damaged during maintenance, the product is the same. So flour will always be in contact with the same kind of product, the same kind of material, plastic. So there is no problem of contamination. Also, wood is a living material, so it reacts to environmental conditions where it is. And many times in sifters, we have conditions of humidity and temperature that deform wood. And when wood deforms, we have cracks between the frame and the sieve. And so these cracks open, and these cracks facilitate contamination of flour. Whereas on plastic sieves, we have a much more stable material, which is not deformed by temperature or humidity. Also, the welding on the sides make this product undeformable. So, and there is no infiltration problem. Well, from the technical point of view of the two kinds of material, what materials, what can we say? First of all, uh, wood is classified as a composite material, meaning material consisting of fibers and layers combined together through binders like resins or glues. On the other hand, we have plastic sieves, and plastic is a homogeneous material, meaning, as Sergio was saying before, plastic is characterized by the same structures in all its points. So physical and mechanical characteristics are homogeneously distributed within a plastic structure. This is uh, a difference between wood and plastic. There is a more subtle material between non-antimicrobial plastic or green plastic and antimicrobial plastic. The substantial difference is that in antimicrobial plastic, there is an addition of an antimicrobial substance ingredient, which is used to delay formation of molds. This substance, is antimicrobial substance, is somehow trapped in the plastic structure. So once the sieve is operating, it is not worn down through time. Therefore, the plastic sieve is not affected by wear, and it is not affected by products like flour. So there is no contamination to the food products, like flour in particular. From a construction point of view, what can we say? First of all, plastic is a homogeneous material, therefore its workability is very high. It means that high workability means, for example, that plastic can be processed in one passage on one machine tool, just like milling cutters, for example. This essentially allows a number of advantages. So for sure, repeatability of a plastic piece, a plastic part, so the efficiency of production increases. It also allows and increases the precision, accuracy of finished plastic piece, because a plastic piece is finished, it is made on one machine tool, so it doesn't need to be placed on different machine tools, whereas on wood is a composite material, so it requires different processes on different machine tools. In practice, what does it happen? Plastic sieves are more resistant than wooden sieves from the point of view of deformations caused by the pressing action of sieve press or environmental conditions like humidity, for example, moisture. Plastic materials in this case have a number of advantages because Ocrim has not only replaced plastic, so wood with plastic, but we've also added technical solutions improving and increasing mechanical performance like the autogenous welding. We can see this kind of welding on this piece, on this part. This welding techniques is used to weld the plastic components forming the corners, the frame of the sieve, and there are a few advantages. If I try to deform this geometry, look what happens. You can see 90-degree angle doesn't change. This means, as I was saying, strength of plastic sieves increases under the pressing action of the system. On the other hand, the welding does not require any addition of material, so parts can be perfectly welded together. So the sieve becomes a single piece. So unlike the, the previous materials, there is no product infiltration inside the sieve. From the functional point of view of a system, a plastic sieve, as we all know, uh, sifters require uh, cleaning frequencies which is not lower than 2 or 3 times a year, and it varies according to the environmental conditions of the location of the machine. The use of a plastic sieve reduces the frequency of this kind of maintenance activities. In fact, in case of antimicrobial plastic, we can reduce to the frequency of cleaning of sifters because thanks to these innovating materials, we can delay the formation of molds and bacterial loads. Can you confirm this, Sergio, from your experience? Yes, in fact, we're now selling this material since 2017. So in the last few years, we have also done some tests. So I've opened canals working for a few years now. There is less accumulated material. In the case of antimicrobial material, there are less moles or less accumulated material, less moles. So it's become much easier to control bacterial proliferation within a meal. Something else we need to say that the standard is a plastic sieve. So we give it for granted that um, wooden sieves and plastic sieves are interchangeable. Concerning now the frame, what is a frame? A frame is this structure consisting of aluminum rods combined together and screwed together sometimes, which supports the sieving mesh. The range of frames available at Ocrim, so the choice of the frame depends on the customer's choice and need, according to the product customers require. The first difference characterizing Ocrim's frame is referred to the number of sectors in the frame. For example, this frame is used on small sifters, SFIS, on the SFIS model, and sieves are 650 by 650 with 0.34 square meters sieving surface. Concerning larger sifters, we use this frame, this solution. In fact, we decided to increase the number of sectors from 6 to 9 so that the surface is larger, the sieving surface is larger, there is an equivalence and a homogeneous cleaning of the sieving surface. These sieves are used, as I said, for larger sifters, SFIL, where we used 750 by 750 sieves with a net sieving surface of 0.43 square meters. Another difference characterizing these frames is related to the height. So the difference between a sieve with or without mesh. In fact, in sieves without mesh, we have been able to reduce the height by removing the mesh. We reduced the height by about 10 millimeters. This involves a total height reduction of sieves to introduce more sieves, therefore more sieving meshes, thanks to the reduction of frame height. For these frames, for sieves without mesh, we use this kind of ejectors. We use cleaners ejectors, 2 in 1, and with the brush, they clean the mesh, the sieving mesh, and with this specific tip, they expel ma material through these openings. So in the more traditional sieve, flexibility of plastic allowed us to keep these sieves. We can still use a tip tap. A tip tap is characterized by the presence of this part which jumps on the mesh and cleans the sieve, whereas expulsion of product is guaranteed by this urethane elastomer ejector. Another characteristic of the frame is the addition of this L-shaped part, which is the perimeter of the frame. This L-shaped profile allows two things. First, we can perfectly seal the part above the mesh once it is in this housing with the lower part of the mesh. So through this L-shaped part, we have created a sort of a labyrinth, avoiding the passage of product from above to below. So there is no contamination. This L-shaped frame also has a number of solutions of grooves on the surface, and the mesh can be perfectly glued, and the mesh is always has the perfect tension during operation. The gluing operations and tensioning operations of the mesh are made through a totally machine controlled station in our workshop. So the quantity and position of the glue is done by a robot. So the quantity of glue and application of glue is totally machine controlled. Now I would like to give the floor to Sergio concerning the choice of ejectors for cleaners on the frame. My opinion, the choice is quite easy because, as many of you have seen, when you open a sifter and you find this mesh full of flour products being there for weeks or sometimes months or tip tops, they are worn down, was normal. So cleaning it and changing the cleaners becomes quite a long, complex operation with Sieves without mesh, we have solved this problem. So we remove the mesh, and so this source of contamination is removed, and the replacement of cleaners has become quite easy. During any regular cleaning, we can change them with no difficult operations. We're also talking about cleaners. Ocrim had already checked and saw that for finer flour, cotton tip-top cleaners were more effective than plastic tip-tops. So we decided to use cotton tip-tops up to 250 microns on nylon webs, whereas on larger nylon or stainless steel webs, we use plastic tip-tops. We did the same with the new cleaners ejectors, where we have flour cleaners, where we have nylon. Cleaning is more efficient with the brush, whereas on stainless steel and nylon seals, so larger than 250 microns, we use cleaners with ashlars, with stronger work, with a specific clean. As you said, something else important on the new sieves is L-shaped frame. In fact, when we work with wooden sieves, the frame was inside the sieve. And in case of deformations, this crack opened, and there were just tails and ribbons there, ensuring the sealing. But then they became less efficient, so flour could be contaminated more frequently. Instead, with this L-shaped frame, the frame sits between the sieves and it creates a labyrinth, as you said. So the product cannot be contaminated as it was the case in the past. You also said that with a cleaner ejector, we have been able to reduce the height of the sieve by 10 millimeters, 10 millimeters per sieve. So in canal of 30 seeds in a plant sifter, we have such a large space that we can add two or even three seeds, so the sieving surface increases. I can show you an interesting video where we can see on the left a B1, B2 canal where we have changed the sieves from wood with the mesh to a modern plastic sieve without mesh. The efficiency is quite clear here, which is due to both the fact that the frame is larger, as a larger surface, and also we could add more seeds. And since it is divided into 9 sectors, each cleaner is dedicated to a lower surface, so we have optimized the cleaning of the sieve. And this is the result. You can see in this video. Thank you very much, Sergio, for your contribution. Now we'll give you the opportunity to ask questions that we receive from our chat. So I would start with the first question. What kind of information do we need to propose technological diagram? For technological diagram, we need to know the quantity of product we receive in our canal and its specific weight. Its granulometry, so its coarseness, and these values are entered, these parameters are entered in a spreadsheet, and then we enter more parameters that we have obtained through time. Then we find the volume of the products passing on our sieve. Of course, for sieving B4 product is quite different than other finer materials. Once we have this information, considering also the diagram and the products we want to obtain, we decide the kind of the sieve with one outlet or two outlets, the height of the sieve, its shape, and also the um, seams we can introduce between the sieves so that the product can pass through. Second question. Uh, Plastic used by Ocrim is appropriate for food contact for a long time as well as for accidental contact. And we have a certification which is compliant with all European and American standards. Next question. What is the difference in terms of costs? In terms of costs, in terms of costs, we can say that now Ocrim has been able to make plastic standard material. So the cost of making plastic sieves lower than wood. So for customers, buying plastic sieves is cheaper than wood. And of course, antimicrobial plastic is a further step. So the cost is higher, but for details, you need to speak to our specific offices at Ocrim. We cannot provide prices. Next question. Is it possible to install these sieves in non-Ocrim machines? We had this question also in the previous sessions. Of course, the flexibility of Ocrim's plastic sieves allows us to use these plastic sieves in any machines, even if these are not Ocrim machines. The only thing we need to check is that we give interchangeability for granted between wooden sieves and plastic sieves in Ocrim's machines. So then, if it is an Ocrim machine, uh, for sure we can do it. For non-Ocrim machines, especially machines built before the year 2000, uh, one of our engineers need to make an inspection, not because the sieve cannot be adapted, but these machines need an additional check, and so they need further measurements and inspections. For example, in this morning session, I was saying that last year we we replaced the canals for one of our customers who decided to change its wooden sieves with plastic sieves. They were completely different, and this customer's machine were totally different from ours and before the year 2000. I think the machines were from 1992, so my age, and we could successfully change these sieves and even increase the capacity of the machine. May I answer also the next question? I could see if frame holders can be made of different sizes. So anything that could be made of wood, we can make it plastic. So the new plastic and antimicrobial sieves in any plant sifter of any supplier. So no problem. So the answer to this question is yes. Right. So we've run out of time. I would like to thank Sergio for being here. It's been a pleasure. Thank you for inviting me. I would like to thank you very much for participating in this event. And I remind you that if you have any other questions or doubts, please send us your questions by email to our email address, and we will answer as soon as possible to the email conferenceroom@ocrim.com. I would like to say hello to all people I know and know me. See you next time. Please register to our newsletter so that you receive information about our events. Thank you for your attention. Bye bye.